In the past year, a special test series was conducted to study the behavior of a reactor under destructive conditions. This study was carried out in the SPERT 1 facility, containing a light water-moderated swimming pool-type reactor with a plate-type core. The core consisted of 25 fuel assemblies with 12 aluminum-clad enriched uranium fuel plates in each assembly. These assemblies were placed in a rectangular array, 15 inches square. 4 double-bladed control rods divided the core into 4 quadrants. A double-bladed, so-called transient rod was located in the center of the array. The poison section of this rod could be driven out the bottom of the core, causing an effective step reactivity insertion to initiate a power excursion. In the destructive test series, several types of devices were used to measure temperature, power, and pressure. The temperature measurements were obtained by means of thermocouples, some of which were mounted on the surface of various fuel plates and others buried in the fuel plate cladding. 3 types of boron-lined neutron detecting devices were used to measure the reactor power. Several pulse chambers for use at low power levels were loaded into polyethylene cylinders, placed in aluminum containers, and mounted on the core structure. For the higher power levels attained during the excursion tests, 6 gamma-compensated ion chambers, placed in protective housings, were located in various positions around the core. With the preparations and checkout complete at the reactor, health physics personnel cleared and secured all the SPERT reactor areas and signaled the reactor operator, who then turned on the reactor area exclusion light. This view of the test was photographed from the back of the reactor building at 650 frames per second. Arrows indicate the upper bridge holding the control rod drives, the periscopes for photographing the core, the mirror in which the Serenkov glow may be noted, and the lip of the reactor vessel, which was driven downward during the test. To observe these details more clearly, let us look at the same sequence slowed down first by a factor of 3 and then by a factor of 10. Again, we see the transient rod falling, the Serenkov glow at peak power, the downward motion of the reactor vessel, the upward motion of the periscopes and lower bridge, and the ejection of water and hardware from the vessel. Now the 10-fold slowdown of the same sequence. Note that each time step is roughly 1/650th of a second, or about 1.5 milliseconds. The first close view of the reactor building showed that one of the roof beams had been bent upward, presumably as a result of impact by water or some component ejected from the reactor vessel. Also, a number of lights used within the vessel had been thrown outside the building. The measured radiation levels at the edge of the reactor vessel were only a few roentgens per hour. The first look into the vessel revealed only a confused mass of twisted gray objects. The yellow object is a radiation monitor that has been knocked loose from the side of the vessel.